Hello and welcome to today's session on how to reduce load on master database. I stumbled upon a good read and hence I thought of making this video. Okay, so let's consider a simple setup when you have an API server. Okay, wherein you have exposed it's a service when you have exposed some APIs and you've got a Postgres SQL DB. Okay, this master node and then there's the replica node. Okay, so all the writes and reads are happening on this node itself. Okay, this node is the just for the backup purpose. Okay, it's pulling the data. I mean, whenever the writes are happening on the master, this replica node is pulling the data from this master node. Okay, and this is just for the backup purpose, as I said. That is when the master node goes down. When the master node goes down, this node can be promoted as the master. Okay. Okay. So now what happens is initially it's a new product. Okay. Initially the load on this master DB is low because the customers are few. Okay. But going ahead, the number of customers increase, the load on this particular master database increase because all the writes and all the reads are happening from this master DB itself. Okay. So now what are we going to do? Okay. So since the load has been increased on master node, what we think upon is, okay, let's have some replica nodes. Let's have some replica nodes, okay, which will pull the data from the master nodes. Whenever the writes are happened, the replica nodes will pull the data, okay, and we will route the writes. The writes will go to the master, okay, but the reads will be segregated and they will be routed towards the replica, okay. That is, the reads will happen from the replica, okay. So in order to reduce the load on this particular master node, right? In order to reduce the node on this particular master node. So since we have removed the read load, right? The read load from this master node and 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 we have routed the reads to this replica node, the load on the master is definitely should be reduced. Okay, should be reduced. But now what happens is the reads which are routed to these replicas, which are routed to one of the replicas, okay, one of the replicas, okay, the customers complaining that they are not able to see the data, or they are not able to, or they're able to see the stale data. Basically, they are not able to see the latest data. Now let's see why it is happening. Why it is happening? Okay, why the customer is not able to see any data, the latest data which was written, or the data, okay, which they got was stale basically. Okay, so what happens is, let's consider the setup. Okay, so whenever writes happen, okay, they happen on the master DB. The data is inserted in the master in the table in the master node, and along with that, the DB also makes an entry, whatever write operation was done, right? It makes an entry into a file which is called write ahead log file. Okay, which is called write ahead log file. Okay, so let me repeat, whatever writes happen on the master DB node, it also writes the entry. It makes an entry, whatever was operation, insert, update, right? Whatever was the write operation, it makes an entry into this write ahead log file. Okay, into this write ahead log file. And what the replica does is, so how does the replica get the data from the master DB? It makes a network call from the replica node to the master node. It makes a network call. Okay. And it fetches the data from the write ahead log file from the master node. Write ahead log file from the master node. Okay. Okay. So whatever. So in this write ahead log file, whatever operation was done, insert into this table or update table. Okay. That query is written into this write ahead log file, and the replica makes a network call, reads um, it keeps track of the offset, right, of the write ahead log file. From the write ahead log file, reads whatever was unread, it reads those queries, okay, and then ingest into the replica DB. Okay, so that's what. So now what happens is, since replica node is making a network call, okay, going through that file which is local to the master, okay, reading that and going back and inserting, it takes time. Okay, there's latency. Okay, and because of this latency, okay, so whatever the reads are being routed to the replica nodes, okay, they are either not returning the data because they don't have the data, or they're returning the stale data. So this is the reason. This is the reason they are making the network call, going through the val file, okay, and then ingesting into the replica DB. Okay, this is the reason. It creates latency, right? Because it's making a network call. Okay, and that is why the reads are miss or the reads are, I mean, stale basically. Okay, okay. So this is the reason. Now how can we still solve this problem? Okay, so what are we going to do is we'll have two paths now, as I said, right? We segregated two paths. One was the write path and another is a read path. Write path is going to the master node, okay, and the read path which are the reads basically are being routed to the replica nodes. Okay, so now let's see the solution. Okay, so what happens is you get um, uh, an API is called, put post API is called, you get the writes, okay, and you ingest the data into the master node. You ingest the data into the master node. Okay. Along with this, once the writes are done, once the record is ingested, right? Once the record is ingested, okay, into the master node, the API server, what it does is it fetches, the latest LSN. Now, what is this LSN? LSN is nothing but log sequence number. Okay. Now, what happens is, let me tell you. Now, I have already mentioned, right? There's a val file, which is write ahead log file. Okay, write ahead log file. And I also told you whatever the writes were happened. Okay, all those write entries are made into this val file. Okay, into this val file. Now what happens is whenever this entry is made, okay, there's this log sequence number also being written. For example, so one of the writes came that insert into. This was a, let's consider this was a first write. Right. Now what happens is there'll be log sequence number which will start, which is a monotonically increasing number. Okay, it starts from 1. Okay, okay, 1, which is a log sequence number, and insert into. So this is a very simple representation of what I'm showing you. It's basically the data which is written in the right hand log file, it's into binary format. And it's like the location of the block basically on the disk, okay, wherein the record is getting written basically. Okay, but just for simplicity purpose, it is like the log sequence number and the query. Just consider this. Okay, so whenever the second write come, now update, for example, update some table, right? So this entry is made again here, which is monotonous. So now the number will be 2, which is a log sequence number, update into. Okay, update into. Okay, so in the val file, what happens is the log sequence number is written, which is monotonically increasing. Okay, and the query, which is the right query, which is made, it is getting logged basically. Okay, so what happens is, as I told, the write came. Okay, we wrote the entry into the database, into the master node. Okay, we wrote the entry into the master node, and now what we do is the API server will make another call to read the latest log sequence number. Okay, the latest, whatever is the latest log sequence number, it is going to fire a query on the master. This is just a sample query, right, which returns a current write ahead log file log sequence number. Okay, so it will query the master node to fetch the current or latest log sequence number. As I told you, what is a log sequence number? It is the sequence number in the write ahead log file. Okay, so it gets that, it fetches that into the second step, and the third step is it will cache that log sequence number, the latest log sequence number, into some distributed cache like Redis. Okay, into some distributed cache like Redis. Okay, so this is the right path. Okay, it's simple. It writes the whatever the data, it writes into the master node. Okay, then it fires a query to the master node. It reads the latest LSN, and then into the third step, it caches the data. It caches the LSN into the Redis node. Okay, okay. Now this was the right path. Now let's come to the read path. Now let's say some some API, get API is called basically, right? And what it does is, now what it is going to do is, okay, it will fetch the first step. It is going to do, it will fetch the latest LSN from the Redis, which was written in the right path, right? We saw in the right path, the latest LSN was written in Redis. So it fetches that latest LSN. It wants to know, okay, what is the latest LSN? Now, what it is going to do is, in the second step, it will fire, or it will query. Okay, it will send a fetch query, right? A fetch query to all the replicas asking for their latest LSN. Okay, So just want to, they want to, the API server wants to check. For example, the latest LSN was 756 into the Redis, right? So now it fires a query to the replica and it wants to know, okay, what is your LSN number? What is your LSN number? Because the replica node is also right makes an entry into the val file, which is write at log file. Okay, and there's the LSN number as well. Okay, so in the second step, it fires a query to all the in parallel, basically to all the replica nodes to know their latest LSN. So for example, this says I am on 729, this particular replica node. This says I am on 759. Okay, and this says I am on 689. 689. Okay, so now API server gets the log sequence number on from all the replica nodes. Okay, it knows from their LSN number, it knows which is which is the replica node which has at least the LSN, this at least this latest LSN. Okay, so now it gets to know that the second node the second node has a at least 759, which is greater than 756, right? Which is greater than 756. Okay, so it says, API server says that we will get the latest data from this particular replica node itself. Okay, so what it will do in the third step, in the third query, it is going to fire it will fire the read query to read the actual row, right? To read the actual data. It will fire on this particular replica node because it has the latest LSN. Okay, it has the latest LSN. Okay, so in this way, the customer will get the latest read. This time the reads won't be missed or it won't be stale. Okay, because we have fetched the data from the replica node, which has all the latest and greatest data, basically, which is all the latest and greatest data. Now, earlier, what used to happen? It used to fire on any node, right? On any node. And some replica node may be lagging behind. Okay. And the data was either was stale or there was no data being written. Okay. So in this way, okay, the read problem will be solved. Okay, and in this way, the load on master will also be reduced because the reads are happening on the replica nodes, and we are making sure that we are getting the latest data in this way. Okay, I hope you've got this now. But you will say, what we are doing, we are making a call to Redis, then we are making parallel calls to replica nodes, right, to fetch their LSN, and then whichever node has the latest LSN, you are again making query to replica. So this is going to incur cost, right? This is like the reads will be slow now. Yes, it is going to be slow. So now we can consider, for example, what will be the network incur cost here. I think it is going to be 10 milliseconds. Why? For example, if we consider 1 millisecond for Redis to fetch the data, to fetch the LSN number, right? And we can consider maybe 2 milliseconds or 3 milliseconds, right? 3 millisecond to or maybe it is going to be 2 or 3 milliseconds, right? And this, for example, to fetch the latest LSN, this is going to be in parallel, right? All this will be parallel. So it is going to be what? 3 millisecond, 1 millisecond, right? 1 millisecond plus 3 millisecond, and again we are going to make a query to the replica, which will have the latest data, right? So another maybe let's add 2 millisecond or 3 milliseconds, let's say 3 millisecond. So in this way, it comes around 7 millisecond. So we are paying a cost of 7 millisecond, I think, which should be tolerable for most of the cases. Now, this I had read from Atlassian blog, okay, and they were okay. They were okay with paying a cost of 10 milliseconds, with incurring a cost of 10 milliseconds, okay, because they're the right problem, basically because their master node, the load problem, right, it was solved, and they were okay with 10 millisecond incurring the cost, basically. Okay, so I hope you've got this. Okay, thanks for watching. Thank you so much.